Hello, my name is Scott Bigelow, and today I'd like to talk to you about using Flashbots for White Hat token rescue. In this talk, I will be covering what Flashbots is, what a White Hat token rescue is, how it is that people end up needing these White Hat token rescue services, how these private keys end up getting compromised, and we're also going to look at how you can create a White Hat rescue bundle if you had any tokens of your own that you needed to rescue. And then in a second video, we'll be doing a live demo of creating these bundles for your accounts and tokens that it's going to run on the Goerli network. In this video, you are not going to need any knowledge of Solidity or programming, but you should have a fairly firm understanding of how Ethereum works and how transactions are confirmed. So what is Flashbots? To answer that question, we should discuss how transactions are normally propagated and mined on the Ethereum network. This is a diagram of the Ethereum network, sometimes called the dark forest. Here we have miners that are hanging off the edge and receiving gossip from the network. And so when you have your transaction here, you will submit it into the network via gossip, via your own node, which will bounce around a whole bunch of nodes and end up in the mempool of these various miners and will eventually get confirmed into a future block. So this is not at all how Flashbots gets transactions to miners. First thing to note is that Flashbots does not send transactions. Flashbots sends an array of transactions in a specific order. This array can be an array of size 1 if you only had one transaction to confirm, but we normally talk about these things as a bundle of transactions that are to be included atomically and in a specific order. And instead of sending these to the mempool, you send this bundle to a relay. This is a server running that knows all of the contributing miners that have integrated with Flashbots. So when you send this bundle to the Flashbots relay, the relay will push these to the private endpoints of supporting miners, which will then perform the same function. It will include these in a future block when one of these miners wins the race. So Flashbots is a service that allows you to submit an ordered list of Ethereum transactions, and it avoids this public pending pool. And if you'd like to learn more, here's a link here under flashbots/PM on GitHub. So what is White Hat token rescue? So when we talk about White Hat, we're talking about some sort of a person that would be considered a hacker, but generally uses their skills to help people that have been impacted or to notify projects or services of issues before a black hat can take advantage of them and cause harm to user assets. So how does this apply to crypto? Well, in crypto, when we talk about White Hat, we generally talk about ways that we can either rescue assets from being stolen by hackers or how we can prevent them from being lost in the first place by reporting these vulnerabilities. In the White Hat that we are discussing here, we are talking about rescuing tokens that rightfully belong to users but have been attempted to be claimed by hackers. So how does one end up needing a White Hat token rescue? One of the ways that's most common is by users leaking their private key on accident. For instance, they might come to some sort of a site here. This is going to My Ether Wallet, and they might think that they are on My Ether Wallet or whatever dApp it is they think they're interacting with, without realizing that they're actually not at that site. Where there is something that has a similar URL, has a similar look and feel. Most of these are open source projects, so it's not terribly hard to emulate. And they will submit their private keywords or private key or whatever it is that they have that has access to some tokens on the Ethereum mainnet. And once they do that and they click continue here, it's over. They have taken their seed words that they were never supposed to share with anyone, and it has gone straight to an attacker's servers, which will then take these assets and immediately withdraw them. They will, within 1 minute, probably all assets in that user's account will have been put into the hacker's account. Save for one type of token. If there is a token in their account that is locked, normally because it is staked under some sort of a time lock or some sort of complex lock that the that the attacker couldn't figure out, then it will often be left there until the time that either the hacker can figure it out or that time lock expires and then they can try to withdraw the assets later. But given that you have a little bit of time here, you have understanding of what's going on, the victim might think that they can attempt to rescue these tokens when the time is right if they just act fast enough. So their idea normally is here's their hacked ETH account. Here is some new account where they have acquired some new ETH in order to perform actions on Ethereum. There's their ERC20 contract. So they'll think, okay, well, I'm going to take 0.1 ETH and I'm going to, at the right time, fund this hacked ETH account with enough to pay for gas on Ethereum so I can run a second transaction which transfers these ERC20 tokens to a new address, often this account here, but it could be anywhere, somewhere outside of the control of this hacked ETH account. So they do this, so the day comes, they transfer 0.1 ETH into this hacked account, and they get ready to do that second transaction, and that ETH is already gone. Since that hacker has their private key, they are able to very quickly just take the ETH way before they could ever dream of getting a manual ERC20 contract interaction on the wire. This will often happen next block. So what we need to do in order to rescue these tokens is to take these two transactions that power the extraction of these ERC20 tokens into a new address and bundle them together. We need to take these two things and make them atomic and include it in the exact same block. So there's no way to get in between here to allow a hacker to withdraw the ETH that was intended for gas. And to do that, we wrap them in what we call a Flashbots bundle, a way to package up multiple transactions to be delivered to the miner, requesting that the miner includes them in sequence or not at all. This works great. We have actually done many token rescues this way, but there is a problem with this methodology. And that is that Ethereum transactions, after they appear in a block, are not actually final. They're often final. When you include something in a block, it's likely going to be a part of the Ethereum blockchain from then on, but there is something called a reorganization, which can cause one block to actually not be the one that wins, and then the transactions that appeared in it are free to be included in a later block. So even though the miner did the right thing and included them in an ordered fashion in one block, it doesn't necessarily mean that that block is going to win, and those transactions could end up back in the pending pool, and the problem starts all over again. So if we take this bundle and we split it up, and this transaction is targeted for inclusion in a different block, maybe the next one after, we can see the same thing happen. This transaction gets included, and this hacker withdraws 0.09 ETH into their own account. So even though this way would work, I really don't like even the possibility of giving a hacker 0.09 ETH whenever there's a reorg. So let's look at a different method that we can use to extract these tokens from compromised accounts that doesn't include the possibility for hackers to benefit. So we're starting another rescue attempt here. But instead of pre-transferring in to this hacked ETH account 0.1 ETH, let's actually just create a transaction that asks the ERC20 contract to move the tokens to a new address, but uses a zero GUI transaction to do it. This way, even if there's 0 ETH in this hacked ETH account, which there likely is because the hacker withdrew it, you can still run transactions because you're actually not paying anything to use them on the blockchain. Now, the miner needs to get paid somehow. They're not going to include your transactions for free. So we'll include a second transaction that comes from an account that is different, that has ETH in it already. And again, it's going to run at 0 GUI, but it's going to include a little bit of value, ETH value, in the same way you might transfer value from one wallet to another. And it's going to call a special contract, which is designed to check that a behavior has happened on the blockchain, in this case, that tokens were indeed moved to a new account, and only if that was the case, transfers the value that came into it to the miner, to the block.coinbase. Now, let's take these two transactions and include them in a Flashbots bundle. Now, let's walk through what happens if either of these transactions gets put into their own block due to an Ethereum block reorganization. If this transaction is put in the wire by itself, well, that's great. We have just transferred these tokens from the hacked account to the new account. And by the way, we did it for free, so that's wonderful. If we isolate this transaction and this one doesn't actually make it in, well, then the check and send is going to say, hey, does the new account have the tokens? No? Well, I'm not going to pay the miner anything then. And again, this is a zero GUI transaction. So neither of these accounts have really paid anything for this execution, even if these were to get maliciously included into a new block. And so when we look at these two transactions in order, we have achieved some sort of an account abstraction. And this is a term that we use for having one account that owns assets and runs execution on the EVM from the perspective of that one account, with a different account paying for the gas to do so. So how does one create a Flashbots bundle? How do you create these signed transactions that appear in an array to be delivered to the Flashbots relay? Flashbots has released several open source projects that help searchers, what we call people who submit bundles to the relay, that help searchers create signed transactions that accomplish their goals. We have libraries in Ethers, we have libraries in Python, we have more libraries coming out. We also have higher level projects that use these libraries to perform basic tasks. And in the next video, we are going to pull up this project and modify it for our needs and move around some assets on the Goerli network, even though the account that is executing those actions doesn't have any Goerli ETH to pay the miner for those services. And yep, I'll put the link to the video over here. And if you're interested, I'll see you there.